using the host as the production factory. The problems that we ran into when we first started developing this was the RNA was highly inflammatory, which meant that if you injected it into a mouse, the mouse got sick. Nobody wants a drug where if you inject it into somebody, they get sick. So we spent years trying to understand why the RNA was so inflammatory. And that's where we made our key finding, which is how to make the RNA non-inflammatory. That also happened to increase the amount of protein that was produced, which was a great secondary benefit. So Katie and I have worked together for nearly 25 years, and it took the two of us together to solve the problems of mRNA therapeutics. Bob's work was in the development of delivery systems. It was actually Peter Cullis who developed the lipid nanoparticles, but Bob has developed similar platforms, and Bob started Moderna. And Moderna and BioNTech were the two chief companies that made mRNA vaccines for the mass populations. So it was really, all three of us had separate but important contributions to making these vaccines work. Yeah, so vaccines are incredibly important, especially this one that's been given to over 1 billion people and will hopefully end a pandemic. But RNA has such incredible potential for so many other diseases. We just published a paper where we delivered CAR T cells in vivo. So what that means is we gave a single injection to a mouse and the CAR T cells cured a disease. It currently takes 2 weeks to make CAR T cells and $500,000. In addition, we're developing therapies for in vivo gene therapy. For sickle cell anemia, 200,000 people a year are born with sickle cell. We hope to be able to give them a single IV injection of RNA LNPs that will target the bone marrow stem cells and fix the genetic disorder, curing the disease. That would change medicine. So, I've got a few things that I'm working on. I mentioned two of them just recently. I think one of the most important things I'm working on is training the next generation of researchers, training young people to become principal investigators, running their own lab, making their own therapeutics, so that the research of therapeutics continues forever. The ideas that Katie and I came up with are just stacked on top of everybody else's ideas over the years. And we need to have young people take over for us and take those ideas and expand them, improve them, and build the next series of therapeutics.